Okay, so let us revisit this example once more. So recall that the feature that we had was that there were three players and the coalition function was given as following, that you have got V1 equal to 6, V2 equal to 12, V3 equal to 18, V12 was 30, V13 was 60, V23 was 90, V123 was 120, and V5 was 0, right? And we calculated using the axioms and showed that the Shapley value of this game was 22, 40, 58. In the previous video, there was a typo where we had 22, 58, 40, but now this has been corrected and you can take a look at the slides in case you have doubt about the correction. Okay. All right. So now what we are going to do is we are going to be looking at a slightly different way of calculating the Shapley value for the same game instead of splitting the games that we have had so far, right? And this second way is going to kind of shed more light about how to think about Shapley value in a very different way. Okay, so we are going to be thinking about the following. So consider a procedure in which the three players that you have, this 1, 2, 3, they are going to enter a room in any order, and each player that enters the room is going to receive his marginal contribution to the coalition of players waiting for him in the room. Okay, so at first this might seem a bit mysterious, but let's just see how it works out in this example, right? So since they're going to enter the room in any order, let's just pick a particular order to begin with, and then we'll see how things work for the other orders, right? So suppose that players enter the room in the order 2, 3, 1, right? What that means is that initially there's an empty room. First person 2 is entering, then person 3 is entering, and then person 1 is entering. Okay. Now, since there was an empty room at first, the value of the coalition was the value of this empty coalition, which was equal to 0, right? Then what you had was person 2 was entering. So then the coalition in the room was V2. And so therefore the value of the coalition in that point becomes 12, right? So what person 2 is going to get for this particular order is that 2 is going to receive his marginal contribution, which is 12 units, right? 12 minus 0. So that's how you get the 12. Okay. What about after that? So then 3 is going to enter. And when 3 enters, then the coalition that is going to emerge is 2 and 3, right? So initially you had 2, then you have got 2 and 3 coming in, so that the value of the coalition is now going to increase from 12 to 90, right? So at this point, 3 is going to get his marginal contribution, which is given by 90 minus 12. So what is the value of the coalition now versus what was the value of the coalition before he entered the room? And so therefore 3 is going to receive 78 units, okay? Finally, 1 is going to enter. And as a result of that, now you have got a coalition which consists of 1, 2, and 3. The value of that is 120 units. And 1 is going to receive his marginal contribution, which is the difference between the value of 1, 2, 3 minus the value of 2, 3, which was there before he entered the room. So 120 minus 90. So 1 is going to receive 30 units, right? So we can now summarize that if this was the order of entry into the room, 2 is entering first, 3 is entering second, and then 1 is entering, then the marginal contribution of the players can be given by 1 is going to receive 30, right? 2 is going to receive 12, and 3 is going to receive 78, right? In the way that we did it. But this is for one particular order, right? We have to actually take into account all the other orders that are there. And because you have got three players, so therefore there are 3 factorial ways of entering the room in different orders, right? So you can have 1, 2, 3, 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 1, 2, 3, 2, 1, right? These are the only 6 possible orders. And we are going to consider that each of these possible orders, all of them have equal probability, right? So framed it in this way, the Shapley value is the expectation of the players in this procedure, which is basically the average of the payoffs that they receive, right? Okay, so you can now do the same calculation. So we just did this calculation of 2, 3, 1, but you can do the calculation for 1, 2, 3, right? So I can just quickly go through that. Just to make sure that we are all on the same boat. So V5 was 0, then 1 entered, and therefore 1 received 6. After that, 2 entered, and therefore the value went up from 6 to 30. So therefore, then 2 received 24, which is the difference between this and this. and then 3 entered, and therefore 3 received 90, right? Because now 120 and it was 30 earlier, right? So you can kind of like just note it down here. And similarly, you can easily kind of like find out for all the orders what are the different marginal contributions. Okay. Now, for these 6 orders, you can kind of like, we need to look at the average. So first thing to do is to sum up all these things. So if you sum up the marginal contribution for one for all these different 6 cases, you end up getting 132. For 2, you end up getting 240. And for 3, you end up getting 348. And the Shapley value is the average, right? So you need to then divide it by the number of cases, which is 6, right? So 6 possible orders, each of which has probability 1 by 6. So therefore, the Shapley value is given by 132 by 6, 240 by 6, and 348 by 6. If you do the calculation, you end up getting 22, 40, and 58. Okay. So there is a mathematical result, right, which we are not going to prove here, which says that the Shapley value of player I is the average of his marginal contributions that are paid out over all possible orders, right? This is exactly the result that we used here when we kind of like calculated the total marginal contribution, and then we divided it by the probability of the different orders, right, to get the average of the marginal contribution, right? So this is the mathematical result which allows us to calculate Shapley value in this way, right? So this is the second way of calculating the Shapley value. Okay, even though we are not going to be looking at a proof of this, let's see how it is applied in different contexts, right? So first, let's consider a simple 2-player market game where you have got n equal to 1 and 2. We have got v1 equal to 2, v2 equal to 3, v1 2 is equal to 10, right? So here, because you have got 2 players, there's going to be just 2 different orders of entering, right? Either 1 enters first followed by 2, or 2 enters first followed by 1. So let's think about what are the marginal contributions in each case. So let's first consider 1 enters first, and then after that 2 enters. So initially the empty coalition had a value of 0, so 1 was entering, so therefore marginal contribution is 2, and then 2 enters, and that brings up the contribution to 10. So 2's marginal contribution is 10 minus 2, or 8, right? What about the order 2 first and then 1? So in this case, 2's marginal contribution is going to be given by 3, and then 1 is entering and increasing the value of the coalition to 10. So therefore, 1's marginal contribution is 7. Again, you add up the total marginal contribution. So this is 9 for 1 and 11 for 2, and then you divide it by 2 because you have got these 2 possible orders. So therefore, the Shapley value for this case is going to be given by 9 by 2, comma 11 by 2. Okay, so that's the way in which you do it. Let's now look at a bit more complex problem, right? So this is a problem which involves actually 2 buyers and 2 sellers. So therefore, it has 4 players, 1, 2, 3, 4. So basically 1 and 2 are the sellers, and 3 and 4 are the buyers, right? So this is a generalization of this previous example that we had considered, where you had actually 2 sellers and 1 buyers. Okay, so v1 equal to 100, v2 equal to 100. So as before, they initially had some good which was worth 100 each to them, and you have these 2 buyers who have nothing to begin with. Okay, now if there is a coalition of 1 and 2, then there's no trade taking place as just as before. So therefore, v1 comma 2 is 200, right? They get to keep these goods with them, which is worth 100 to them. And if there is a coalition of just 3 and 4, again, there is no trade because these are the 2 buyers, right? So there's no kind of like trading with the sellers, right? They are not coming to an agreement. So v34 is equal to 0, right? Okay. What about if trade takes place? So imagine that a trade takes place between 1 and 3. So we can imagine that there is some positive surplus that is kind of like generated by both the parties. So then perhaps v13 is 150, right? And the situation is kind of like similar for 1 and 4. So v14 is also 150, v23 is 150, and v24 is 150, right? So this makes intuitive sense. What happens if you have got 1, 2, and 3 coming together? So then here basically only one of the goods is going to be sold, right? And that we have already seen would generate a value of 150, but the other person gets to keep the good. And so therefore, we are just adding 100 to the 2 previous cases. So v1 to 3, where you have got more sellers than buyers, or v1 to 4, where again you have got 2 sellers and 1 buyers, that's going to lead to a value of the coalition being 250, right? What happens if you have got 2 buyers and 1 seller? Well, in this case, only 1 trade will happen, and therefore, again, the value of the coalition becomes 150, right? And finally, if you have got 2 sellers and 2 buyers, it's as if we are adding up this previous case, right, where both the trades take place and the value of the coalition is total 300, right? So this is the overall situation. And what we are interested in doing is calculating the Shapley value of this game, right? So before we get on with the calculation, let us just note a couple of points which will be important later on. So one thing to note is that 1 and 2 are symmetric and players 3 and 4 are symmetric, right? So let's first see why 1 and 2 are symmetric. So we can see that V1 equal to 100. If you just interchange 1 with 2, you end up getting V2, which is also equal to 100, which is good. Then we observe that V1 3 and V2 3 have the same value, right? And V1 4 and V2 4 have the same value, right? So if you interchange again 1 and 2, you end up getting the same value, right? And similarly, V1 3 4 and V2 3 4 are also the same. So from here, it follows that 1 and 2 are symmetric, okay? The second observation is that 3 and 4 are also symmetric, right? Again, you follow the same procedure, V3 equal to 0. If you interchange 3 and 4, V4 is also equal to 0. Then you observe that V1 3 and V1 4 are the same. So interchanging 3 and 4 doesn't change anything. Similarly, V2 3 and V2 4 are the same. Interchanging 4 and 3 doesn't change anything. And then we observe that V123 and V124 are also the same, right? So again, here there is an interchange of 3 and 4 that again leads to the same outcome of 250 each, right? So keep this in mind. We are going to be using this later. Okay. So since you have got 4 players, right, we have to consider all the possible orders. So this is basically all the different ways of entering is given by 4 factorial, right? First one of the 4 will enter corresponding to that, one of the 3 will enter corresponding to that, one of the 2 will enter, and so on, right? So it's 4 into 3 into 2 or 24 different ways, right? So we have listed out all the 24 different ways here. And this is looking at player one's marginal contribution, okay? You could have taken any other player, but let's just do one particular player, let's say player one, and we'll see what is the response we get after that. Okay, so what do we have? Initially, you had the value of the empty coalition as usual being 0, and then 1 enters, right? So 1 is going to get 100 in this case, right? So that's where you get this number 100. Similarly, all these cases where 1 is entering first, you end up getting this number 100, right? Okay, let's consider some other cases. Suppose you are looking at 2, 1, 3, 4. So initially, again, 0 was there, then 2 entered, which is 100. Once you have got 1 and 2 entering, so that goes up to 200. So 1's contribution is again equal to 100, right? What happens in this 2, 3, 1, 4? So initially you had, at the time 1 is entering, you had already 2, 3. So 150 was there. And now 1 is entering. So you end up with 250. So again, the marginal contribution is 100, right? So you can similarly kind of like look at all of these different cases that are out there. And then after looking at the different marginal contribution for each of the different orders, what you can do is you can add up all these cases, right? So if you do the addition, which will just involve a bit of calculation, what you will end up getting is that the total of this different 24 different numbers that you see here, that's going to add up to 3000, right? So then what is the average of player one's marginal contribution? This is 3000 divided by 24. Why 24? Because remember, there are 4 factorial ways of getting the order. So therefore, this is 125, right? Now, we use the fact that players 1 and 2 are symmetric. So that tells us by the symmetry axiom that the average of player two's marginal contribution is also going to be 125, right? So this is remember this axioms that we talked about in when we were discussing the axiomatic approach. So the same axioms kind of like can be of use to us here, right? Even though we are not splitting the game in the different ways that are there, right? Okay, so in terms of the Shapley value, we have got that the payoff to player 1 would be 125, player to payoff 2 is also going to be 125. Now, the efficiency axiom would say that the player payoff to each of the players, if we add them up, that has to add up to 300. We have already found that the payoffs to player 1 and 2 is given by 125 each. So therefore, the total payoff to 1 and 2 is actually given by 250, right? So therefore, the total payoff to 3 and 4 has to be 300 minus 250, right? Because the total to 1 plus 2 plus 3 plus 4 is 300. Total plus to 1 and 2 is 250. So therefore, 3 and 4 are going to get 50. Now, players 3 and 4 are symmetric as well, as we had discussed. So that means that the amount of payoff that is going to each of 3 and 4 has to be equal. And so therefore, that has to add up to 50 by 2, right? So 25 each is going to go, right? So in this way, this complicated looking game that was there, we have managed to actually kind of like get the Shapley value. And the final answer is that it's going to be given by the first player gets 125, the second player gets 125, the third player gets 25, and the fourth player also ends up getting 25. So you can see that we use this second way of thinking about Shapley values in terms of the average of the marginal contribution, and combined it by thinking about these axioms to develop a way of systematically working through problems involving computing of Shapley values.